Welcome back to another edition of Tooling Time. My name is Chris O'Keefe. I'm the lab technician for All-FillInc Incorporated and auger fabrication. Today we're going to be talking about the importance of flake blades and how they can drastically improve the efficiency of your auger filler. Okay, so some products, they're a leafy, light density flake material. This is parsley flake, so it's a perfect example of what we're talking about. The density is incredibly low. And that presents some unique challenges when it comes to material handling inside the auger filler. The surface of the auger filler hopper is pretty smooth. It's polished stainless steel. When you add a light density material like a parsley flake that is able to hook and kind of grab itself, and its density is so light, you run into the issue with a standard slow speed agitator like we highlighted in the other videos. Looks like this. As it sweeps the outside of the hopper, it's actually grabbing the entire mass of material and dragging it around the hopper. So you'll either see it skip or the entire mass will actually spin inside of the hopper. And what that does is you're not creating effective agitation. So a good agitation blade should be cutting through the material in the hopper to the best of its ability. With a slow speed blade, you're not cutting through with materials like this. You're grabbing it and dragging it. So you're not actually agitating the material and getting it to fall into the tooling of the auger filler. So you'll notice it'll starve, your cycle times will change, you'll see weight differences from cycle to cycle, especially on a volumetric filler. So a flake blade was designed to alleviate that issue. A standard flake blade looks like this. So the auger would be here, and now instead of having a tapered profile that follows the inside diameter of the hopper, this focuses primarily around the outside edges of the auger itself. So you're getting the material around the auger to collapse, and you're better cutting through the material using a blade like this. So this is kind of the front profile, what it looks like. It's just a small little hook, and it's primarily straight down. What we've run into before is it will actually do what we call rat hole. So as this is spinning around the agitation blade, or as it's spinning around the auger, it'll hollow out the material around the auger, and that light density material on the outside edges isn't being agitated at all. So what'll happen is it'll stagnate, and it'll hook, and it'll just stay there on the sides. So as this spins, you'll get a couple really good consistent cycles, and suddenly the material will stop feeding. And what that is the outside material isn't being agitated at all, and it's not falling down into the tooling. So we've had to make some custom versions of this, where we add what we call tines. So another flake blade, standard flake blade, but we've added these small rods. So here in the lab, we do different adjustable length bolts because we can adjust how much agitation we have inside the hopper. It's really nice for us functionally. Once we figure out the perfect lengths for whatever the material needs for your application, we'll spec those out with engineering, and they'll weld solid rods onto here, so it's a little more food safe. But essentially what we're doing is now you've got the benefit of a flake blade hugging the auger very tightly. So you're getting that targeted agitation around the auger, but also you've reduced the surface area of the outside agitator, and you're able to cut through the material better. So these rods are super effective at cutting through that flaky light density material and getting it to move. Just enough that it continues to collapse, and then the flake blade can grab it and help fall into the flights of the auger tooling. All right, so what we're gonna do, we loaded the machine up with the parsley flake. What we have in there currently is a standard slow speed blade, and we're gonna show you what a mass turning looks like. So essentially what you're gonna see inside the hopper is the entire mass is gonna be moving. Some products are worse than others. You'll see the entire whole mass of material move all at once. Other times it's gonna be skipping and still kind of cutting through the material. It's a little more efficient than some of the other products. But what you're looking for is for it to kind of stagnate inside the hopper, and that's how you're gonna identify you may need to get into a flake blade. So what we're gonna do next is we're gonna swap out that slow speed blade for this flake blade, a standard flake blade, and see what the difference is inside the hopper. So what you saw in that clip shows the effectiveness of the flake blade. So the mass was no longer turning on the outside of the hopper. It was more targeted towards the center of the auger, center of the machine. But you did start to create a little bit of a valley, a void around the auger. Now, in this case, it wasn't that bad. You'd probably be fine with a standard flake blade agitation. But what we're gonna do, just for the sake of demonstrating it, we're gonna add the customized flake blade to show how this agitation on the outside edge of the hopper kind of helps alleviate that cavity that starts to show up in the center of the machine. All right, so that final clip showed you the benefit of the flake blade with the tines. So what you could see is on the outside of the hopper, that material started to kind of bulge a little bit and rotate around the side. And that cavity that developed in the center of the machine, it's a little bit less drastic. So what you're doing is you've got the effectiveness of the flake blade, getting that material to fall down into the auger. You've got the tines removing the possibility of having a rat hole and a void appear around the auger. So you've got a consistent flow of material with a very difficult light density product. And that's the goal of those different types of agitation blades, is to fix the issues that present with a light density, flaky material. Thanks again for watching another episode of Tooling Time. Keep an eye out for more tips and tricks coming out of the lab here. If you have any questions or any interest in our machinery, please feel free to give our sales team a call at your convenience.